Alright, so our next step is setting up the boundary condition for the geometry. Before we start setup, let's review the boundary condition that has been given in the problem. So the green line is representing no slip wall. Inlet is subsonic normal speed, and it should be constant inlet velocity, which is denoted as U infinity. Blue is the outline, it is atmospheric pressure, and the value is also given to you. The black line, which no slip wall, and front and back surface would be symmetric. The fluid flowing through the channel is water at 10 degrees Celsius. Density and dynamic viscosity is given to us. Inlet velocity is given as 30, 40, and 50 meters per second. Outlet pressure is given to us. Flow should be turbulent using default settings, so we don't need to change the settings for the turbulent flow. And the velocity at walls should be 0, that means no slip wall conditions. Okay, now we can double click on setup to start the setup for the boundary conditions. Alright, so first step is to insert all the boundary conditions and set the boundary condition according to the problem that we just reviewed a few minutes before. So let's insert boundary condition. Let's start with inlet. So write down inlet. Okay, so it automatically locates inlet, and then boundary details. It's already subsonic. It's also selected as normal speed, so we just need to enter here our speed. Let's start with 30 meters per second, then apply. Okay, then right click on it, insert boundary, this time to enter outlet. Okay, so again it automatically locates outlet. Now let's click on boundary details. This time the relative pressure, the pressure has been given to us, which is atmospheric, 101.325 Pascal. Apply. Okay, right click on it, insert boundary. Let's enter front surface. Now this time we need to change the boundary type, which will be symmetry, and then apply. Okay, similar way we can also insert for back surface. Okay, we need to change the boundary type to symmetry, apply. Okay, right click on default domain, insert boundary. This time let's select cylinder circle wall. Okay, again we need to change this cylinder circle wall to wall, and on boundary details it should be no slip wall, so it's there, no slip wall, so we just keep it as it is. Apply. Okay, right click on the default domain, boundary. This time we want to select top wall of the geometry. Again we want to change the boundary type to wall, and this is no slip wall that has been mentioned in the problem, so apply. Okay, similar way we can select bottom wall, boundary no slip, apply. Okay, so we have all the 7 faces has been given the required boundary condition. Now double click on a default domain. The material, we need to change it because the material has been given to us as water, and then click on fluid models. The temperature should be 10 degrees Celsius. Now because alright, so if we want to check whether our flow is turbulent or laminar, let's consider Reynolds number equation, which is rho u infinity d by mu, where density of the flowing fluid water is given to us as 1000, inlet velocity is 30 meter per second, and the characteristics length here is 2 meter, and the dynamic viscosity is given to us 1.3 to the power minus 7. So if we calculate, we get 4 e to the power 7, which is definitely a turbulent model or turbulent flow. That means so our turbulence option, which is K epsilon, is one type of turbulent model. We want to keep it as it is because in the problem it says keep as default setting, so we don't want to change it. So hit apply. Okay. Then expand the materials. Double click on water. Want to change the material properties, so hit on material properties, change the density, which is given to us as 1000 kg per meter cube. Then expand transport properties. Dynamic viscosity is given to us at 1.307 e to the power minus 3, and also the unit is given to us as Pascal second, so we want to change it to Pascal second. And also the reference temperature, we want to change it to 10 degrees Celsius. Once we are happy with this, hit apply. Okay. Next, we want to insert two expressions, one for drag coefficient, the other is lift coefficient. So right click on expressions, insert, click on expression. Let's name it as drag OE. Okay. Now here we can copy our expression, which is given to us in the problem statement. So I just copied from the problem that is given the general equation. Drag is acting in x direction, so that's why we select force at x. Now at the body we want to change it. Delete this, right click on it, select mesh locators 2D, and from here we want to see drag as circle wall, so select circle wall, and then again change this to body, delete this, right click on it, select exactly same way the circle wall, and also we want to change the inlet, so delete this inlet, right click on it, exactly same way, this time we want inlet. You might need to notice that here inlet is written as capital I, which CFX will select as error, so we want to select inlet what it is and then apply. Exactly same way, we can just copy this. Then we want to insert lift coefficient, so insert expression, this time we write lift OE. Okay, paste this time all expression should be same except the force will be acting at y direction. Hit apply. Alright, now right click, now click on outline. We want to select the solver control right now. Double click on it. Minimum iteration, let's try the minimum iteration to 50, maximum iteration 100. And at the moment we don't want to change the residual target. Apply. Okay. Save the project. Now we are ready to run the simulation.